Okay, mass extinction and changes to the environment. Well, we can have this divided into gradual and abrupt. Gradual, okay. Well, currently, what we call continental drift, which is simply the movement of the continents on the Earth's crust. Actually, North America, due to continental drift, is being forced away from Europe by about 2 centimeters per year. I think I have a picture of this. Originally, we can see that there was one giant mass or supercontinent called Pangaea. And from Pangaea, all the other continents formed, and that occurred about 250 million years ago. Okay, you can see. But because of the changes to the environment, organisms couldn't cope, and this is believed to have caused the Permian extinction. In other words, 90% of all organisms were affected by the Permian extinction. They became extinct in the Permian period. If a coastline was eliminated because two continents maybe collided together, then the marine species along these coasts could no longer survive because now there was no water. So this is showing you here the breakup. We're going back to when the continents were one, and then you can see the Permian period, okay. Maybe the continents are all together. So, you know, at first we have this one giant mass because organisms lost the coastlines, okay? So they could no longer survive. The continents kind of collided into one another. Then as you see, things changed over the years. The continents here start to separate. Okay, and you go to the Triassic period, the Jurassic, Cretaceous, and present day, the continents as we know them today. Okay, so there's also belief of abrupt changes. 65 million years ago, dinosaurs became extinct due to an asteroid, they believe, that hit the Earth. And this is believed to have caused what is known as the Cretaceous extinction, which claimed over 50% of all living organisms. And also by this time, the modern continents, as we know them, were shaped, and just as far as the time-wise goes, that's where the continents were at during the Cretaceous extinction. Here's the Permian period. But we look over here, the Cretaceous extinction, the continents are almost formed. But this is the point at which the asteroid hits the Earth and bye-bye to the dinosaurs, right? So here's showing you the different periods. Okay, this is, we look at the little time scale here. You can see, okay, we go back to the Precambrian period. Okay, 3,500 million years ago, we have the first prokaryotes. And then the Carboniferous period begins. Okay, that's 350 million years ago. And we're in the Paleozoic era, and we have the Carboniferous period. And then we have the Permian period, okay? And this is 290 million years ago. And this is when we have the divergence into three main groups: the synapsids, the diapsids, and the anaspids, okay? And this is when the Permian period begins, but we then have 250 million years ago, the continents are formed, and the Permian extinction claims over 90% of all living organisms. Okay. And 230 million years ago, we have the Triassic period. Okay, this is when the dinosaurs appeared, and then we go into the Jurassic period also. Okay, and then finally, at this point, right before the Cretaceous period, okay, you have the 150 million years ago, the Cretaceous period begins, okay, and then 65 million years ago, the dinosaurs became extinct during what's called the Cretaceous extinction, which claimed over 50% of all living organisms. Okay, and that's believed to be due to an abrupt asteroid that hit the Earth. Okay, goodbye dinosaurs, and this is the present era that we're in now, the Cenozoic era. Okay, so you've got these different ideas about the gradual continental drift, okay, and the supercontinent, and then this, changes to the environment. Of course, is going to lead to mass extinctions, and that's the Permian extinction, and then there's abrupt changes also. Okay, okay, and that kind of wraps up our discussion on evolution. So there we go. Evolution is complete.